Hi folks, welcome to lecture 7, and in this lecture we'll be covering percentages in a general sense. So first of all, we just take a look, the old when sums go bad. This is why we do what we do. So the red meat scare, essentially back in 2015, the International Agency for Research on Cancer, pretty much the most respected body in the world for cancer research. They published their findings into the relationship between colon cancer and eating red meat / processed meat. Sometimes it's called processed meat as well. Unfortunately, the media didn't understand the nature of the data. So it was an observational relationship. I'm not going to go into that too much. But really, the media just didn't really understand, first of all, how the data was generated, and secondly, how the data was presented. So they kind of went into hyperbole, they completely misunderstood the dangers of eating meat. They ended up comparing it to cigarettes, asbestos, and other highly carcinogenic substances. The reputational damage to the industry was enormous. They can't really put a figure on it, but it is estimated to easily run into hundreds of millions of dollars of cost. So a little bit of misinformation spread very widely. This was one of the headlines. 50 grams of processed meat is pretty much as dangerous as smoking cigarettes. And this was from The Guardian. Processed meats ranks alongside smoking as cancer causes, and they said it came from the WHO, just to rub salt into the wound as well. So The Guardian would be one of the most respected kind of news agencies in the world, so even they kind of were guilty of this. Now, I'm not going to go into the details of it too much, because that's actually going to be a large chunk of lecture 8 when we start to look at the nuances and where the media got things wrong. So at the moment, basically, we'll just call it misinformation or misunderstanding. But the cost and reputational damage was enormous. And you still see this information being touted as fact on various websites. I was researching into it, and it's still out there. It's still been cited and stuff. So the damage goes on, unfortunately. So we'll just start by introducing percentages. Essentially, a percent is from the Latin, it means per 100. And it's a way of expressing a number as a fraction of 100. So I think we're all familiar with percentages. Denoted by the percentage sign, which we're familiar with. A lot of American textbooks use PCT. Don't see it so much in Europe, but just to be aware, if you do see it, what it means, percent. The most important thing with percentages is we can't, in general, I won't say never, but certainly in science, very, very rarely would we ever use that figure 50 in any cancellation. It's a bit like the mixed fractions. They're nice and pretty to look at, but they're completely useless when it comes to actually doing any maths. A percentage is the same. We need to convert it into its decimal. So we're going to take a look at a bunch of percentages, and we're going to convert them into their decimal equivalents. So just be careful, guys. The process is pretty simple. We simply divide the percentage value by 100. So 50%, I think most people will be happy enough. 50% is a half, 0.5. Maybe what's worth noting, guys, just on a kind of technical level, is the decimal point has hopped 2 places to the left. That's what it does all the time. And if you just remember that, you'll always be safe with percentages. The reason why it hops 2 places is because there's 2 zeros on the bottom. The next one, guys, 5%. This is a very common one that people often write 5% without thinking of it as 0.5. So that's why I'm emphasizing it so much. 5% is 5 divided by 100, which is 0.05. Remember, the decimal point must hop 2 places. The next one, guys, even though you're kind of going, oh, but this is a decimal, It's still presented as a percentage. So often in science, we would often come across this. 0.5% of people suffered from a side effect of a particular drug or intervention. Again, we have to divide this value by 100, and again, the decimal point jumps 2 places to the left. The bottom example, same process. So all the time, guys, nearly all the time, I did put nearly in there because I know of certain business calculations where you would put in the rate as a percentage. So not always, but certainly, guys, as far as this module goes, and I would imagine most modules in first year, you always use the decimal value in your calculation. So if you need to find 5% of something, that's the figure you're going to be using. Be really careful with that, guys. This is the most likely place you're going to trip up with percentages. So however you go about it, just make sure you remember, move the decimal point 2 places to the left to get your decimal. So now we'll just take a look at a few examples. So remember to pause the video. Question 7.1, make sure you record and store your answers neatly. So same as just we did there. Convert the following decimal values into fractions. So regardless, guys, of what the value is, just make sure that you move the decimal point 2 places to the left each time. And then you'll be okay. So take care, and we'll move on again. So now, the main thing with percentage problems is they come in lots of different ways. So your most important technique is ask, which method are they looking for? What's been asked in the question? And then it's a case of applying the correct method to solve the problem. Now, I know that sounds easy, but really this part is the most important. You must identify which type of question they're looking for, and that's what we're going to go over now. In this lecture, we're going to take a look at determining the percentage of a number. Most people are happy enough with that. Determining A as a percentage of B, likewise, most people are okay with that as well. This one, guys, tends to cause issues, so we'll be looking at that at the end of this lecture, determining the original value after a percentage change. So I'll talk about it more when we come upon it rather than elaborating now. Then next week, guys, we're going to take a look at more where percentages occur in science. Sorry, the next lecture, not next week's lecture. So the next lecture, lecture 8, we're going to determine the percentage error. And then we're going to take a look at absolute and relative percentage differences. And this was the main cause of error in the processed meat scare I discussed in a few slides previously. So just to give you a layout, so all this week, guys, will be based on percentages. So the first technique just here, determining the percentage of a number. So the way it'll go, guys, I'll do an example or two, and then I'll set out examples for you guys to practice, and that'll pretty much bring us to the end of this lecture. So the first one, determining the percentage of a number. Turn off the phone. So find 0.05% of 200. Now again, guys, I'm always going to be trying to kind of test you. I really need you to be adept with decimals and being safe around them. I think for obvious reasons, as scientists, we tend to live in the world with decimal places all the time. All our milli, micro, and nano all depends on decimal places. So the first thing, what we want to do, guys, is, like I said, even though it looks like it's a decimal, it is, but it's a decimal percentage. We need to change this into a whole number, into a decimal, into a decimal equivalent, I suppose is the best thing to call it. So we have to divide by 100. Now, like I said, the decimal point moves 2 places. So that's our decimal equivalent. Now, guys, we have 5. Essentially, this is to be multiplied by 200. And don't let your, don't be put off, guys. We've done this before. We have 4 decimal places in our answer. And now we just simply multiply 200 by 5, which gives us 1,000. We need 4 decimal places. So our answer then is 0.1. So that's 0.05% of 200 is 0.1. Now, I'll just clear that, guys, so hopefully you can rewind and all if you need to take a look at it again. So a common kind of addendum to these is when you're asked to increase or decrease, that should be increase or decrease a value by a percentage. The same principle applies. So we'll take a look at a couple of examples of these. And you'll find a good few on Moodle. Now, again, guys, I am trying to challenge you with decimal points all the time. You'll find that now over the next few weeks. We'll be doing a lot of work with decimals, and I hope you'll accept that it's kind of necessary as a scientist. So now we're asked to increase 0.05. We want to increase it by 20%. So we want this much, and then we want to add another 20% to it. Now I hope you'll accept, guys, well, this is the original. We have 100% of the value, and we're going to add 20%. So in total, we're looking for 120% of 0.05. So I've tried to word these problems similarly to guys, but I just want you to notice that they're kind of completely different. The numbers look similar, but the maths is completely different. So now, guys, essentially we're just told, well, we want 120% of 0.05. We need to convert 120% into a decimal. Now, again, guys, I'm doing this a little bit laboriously. Once you know what you're doing, you can kind of fly through it. This is actually 1.2. So that, guys, is now what I multiply 0.05 by. So 0.05 multiplied by 1.2. Now again, guys, I'm just going to do it horizontally. I don't have much space. I have 12 by 5, which is 60. And then I need 2 decimal places and 1 decimal place. So I need 3 decimal places in my answer. And then when I would finally write the answer, I'll just clear this. This would just give us 0.06. Was that right? Sorry, guys. I'm just a very quick check again. I just forgetting my numbers. So 63 decimal places. Yeah, sorry. I just had to double check because there's nothing worse than leaving a mistake on the videos. Okay, yeah, that's grand. Just a subtle point here, guys. If it asked you for this number to 2 significant figures, you would write an extra 0 there. Or 3 significant figures, we get another 0, or 4 significant figures. So just watch out for significant figures. If required, you can just add extra zeros. Doesn't add any accuracy, but just if it's required, sometimes you might need to do that. Now, the next problem, decrease the same value by 20%. So using the same logic, guys, I now have 100%, my original value. So 0.05, but we want to subtract 20% from it. And we're asked, what's the answer? Well, we know in a percentage terms, we must be looking at 80%. So the question now is, well, what's 80% of 0.05? Same logic, we need to convert the 80 into a decimal. And again, guys, you can just do that once you get used to it. It becomes quite straightforward. And it's just literally moving the decimal point 2 places all the time. I hope you get into that pattern. So now, guys, we have 0.05 multiplied by 0.8. That's the 80%. Multiply the two numbers, 8 by 5 is 40. And again, we need 3 decimal places in my answer because there's 2 in the first number. So finally, my answer will become 0.04 for the second problem. And hopefully, guys, again, with practice, Moodle will help you with this. Really how I'd go about these problems when I'm looking at them. I'll just go back to the first one. Increase something by 20%, I would straight away be thinking that's my percentage value. Convert it into a decimal. 120% as a decimal. Multiplied by 0.05. That gives me 60 with 3 decimal places. So you can actually start to work quite quickly through them. And all the time, guys, I'm trying to kind of get you away from calculators. I think you know that. The maths is usually not too hard. It's putting the decimal point in the right places where the skill is. If you're allowing the calculator to do that for you all the time, guys, you are going to be challenged later on in the course. I can guarantee you that. This is where we're practicing these skills so that when we need them later on, you'll be able to employ them. Looking at the other example, guys, decrease by 20%, I'm thinking 0.8. That's 80% multiplied. And again, you can arrive at the answer reasonably quickly. So just my main point, I suppose, is whenever you see decrease by 20%, you could get 20%, guys, of 0.05 and then subtract it from 100 from the original value. So you could say, well, I know this value, and then work out what's 20% of the value. That'll be 0.2 by 0.05. 2 by 5 is 10 with 3 decimal places. So I could say it's 100% minus 20%. And that will again give me the answer. But just going straight, doing this sum first of all, I need 80%. Now, you don't have to worry about any of this subtraction, and that line gets wiped out. So I hope that makes sense, guys. It's a lot easier just to go for the 80% than working out 20% and then subtracting it from 100%. So with that in mind, guys, pause the video and just have a wee go at these problems here. How many students got an A grade? Well, that's 8% of 1,250. Determine 1.2% of 4,500 grams. Increase 200 ml by 20%. And decrease 120 millimeters by 40%. On Moodle, guys, it will just be looking for the answers. Don't try and key in the units. Generally, we haven't got onto units yet, so I'm not really looking for units in answers at all at the moment. So just be careful. The problem, guys, is usually Moodle will be okay if you leave a gap like this. But if you don't leave a gap and you write 200 mil, Moodle just won't see that as either a number or a word, and it'll just give you an incorrect answer. And then you'll be emailing me and etc. etc. So leave out any units at the moment from your answers. So I'll let you guys bash away at that. We'll move on. This is just a typical example of percentages being used in science. You might have come across this yourselves if you're into sport and fitness. So the maximum heart rate of a person is estimated to be 220 beats a minute minus the age of the person. So somebody who's 20 years old, their maximum heart rate would be 200 BPM. For somebody who's 60 years old, we would say 220 minus 60. That will be 160 BPM. So essentially, the speed at which your heart can beat slows down as you get older. And normally we operate at percentages between 40 to 95%. And you hear athletes talking about their resting heart rate. They're looking at this value here. How low is your heart rate when you're resting compared to your maximum? Now, sports trainers and all, these are what's considered light intensity. You'd be working between 57 to 64% of your maximum heart rate. HRM, heart rate max. Figures, and if you're into maximum intensity, you'd be training at about 95%. So you'd be pushing your body to the limits when you're at this level here. And most elite athletes would be including this level of training either daily or weekly, depending on the discipline. So we're taking a look at a client. A client has come in, an 80-year-old lady, and she needs to train at moderate intensity to increase her circulation. So moderate intensity, guys, is here. We're asked, there she is, determine the minimum heart rate that this lady should exercise at to ensure this level of conditioning. So she could be wearing a Fitbit, and the Fitbit would be telling you in real time what your heart rate is. So you would kind of bring your level of exercise up until it's at the required value, and then you would try and maintain that heart rate for however long the exercise regime requires. But what we need to do, guys, is first of all is figure out, well, what's this lady's maximum heart rate? HRM is going to be 220 minus 80. So I just subtract it down here. So it's 140 BPM would be this lady's maximum heart rate. So now we need to work out, well, what's 64%? We're asked for the minimum rate, not the maximum. So we now want to say, well, we want to determine what's 64% of 140. And now, guys, we're into safe territory. Move the decimal point 2 places. Multiply that by 140. So 140 by 64. 4 zeros. So there's my 0 for tens, and then 6 by 0 is 0. 6 by 4 is 24. I just want to double check that. Yep. And now, guys, we need to bring back in our 2 decimal points, or 2 decimal places. So this lady, now BPM is one of the rare areas, guys, where you always actually just settle for the lowest value. So you should normally round up, but in case of BPM, you always just choose the lowest value. We come across a few things like these. Decibels are the same as well. Sometimes you don't round up. So this lady would be advised is go on a treadmill with your Fitbit. Keep walking until keep increasing the speed until your heart rate reaches 89 BPM, and maintain that level then for, say, 5 minutes, 10 minutes, whatever is required. So it's just, guys, to show you where that type of example often occurs in science, especially for sports scientists and sports therapists. Now, the second type of problem, determine A as a percentage of B. To find one value as a percentage of another value, we're actually looking for A over B multiplied by 100. If it's written a little bit fancier, it could be written as the selected value over the total value. This is kind of where we're beginning to talk about ratios written as fractions again, because the total is on the bottom. Won't get into that too much. So find 42 as a percentage of 48, sorry, as a percentage of 72. This is what we're looking for, guys. Now, straight away, I'm actually thinking of cancellation. So I'm kind of looking at this number here. I'm going, well, 12 will go into the top 4 times. 12 will go into the bottom. 12 will go in there 4 times. 12 will go in here 6 times. 2 will go in there twice. So what we actually have, guys, is 2 by 100. It's 200 over 3. And now we just have to do a little bit of division. I made this one a decimal deliberately, guys, because I just wanted to bring in a point. Drop my decimal point down. Ignore it here. Divide by 3. 3 won't go into 2. It'll go into 26 times with 2 left over. And you'll see it actually keeps going, guys, and it would go on forever and ever. Now, in a question like this, guys, if I don't ask you to specify your result to any decimal places or significant figures, 1 decimal place is fine. But remember, in order to calculate your answer correctly to 1 decimal place, we must be able to look over at the next value to see whether we round up or not. So you need to go to 2 decimal places, guys, in order to express your answer correctly to 1 decimal place. So if I don't ask for it, guys, usually, certainly from my module, your physics lecture, chemistry lecture might look for 2 decimal places. If it's not asked for, guys, in maths with percentages, 1 decimal place is fine. But make sure it's accurate to 1 decimal place, because on Moodle, if you didn't go again and look at the next value and wrote in this, you would get it wrong. So just make sure you're accurate when you are going to 1 decimal place. We look at another example, a bit more topical. Just looking at COVID, guys, 20,000 people tested positive for COVID. Ultimately, 700 people in the region died. So what percentage of people died from the illness? So we'll take a look. So this is where we'd use this example, the selected value over the total. So there's 700 people over 20,000 multiplied by 100. Now, just to write that out so we can do a bit of cancelling. This would give us 20,000. Now, guys, I can divide the top by 100 and the bottom by 100. Now I'm going to do the same again. Divide the top by 100 and the bottom by 100. So my answer now actually just becomes 7 over 2%, which is 3.5%. And just, guys, in terms of epidemiology, that number, 3.5%, is called the CFR, the case fatality ratio. And notice how to use the word ratio, even though we're talking about a fraction. Fatalities over confirmed cases. So this is the idea of a fraction can often represent a ratio. So 3.5% is the CFO of COVID in this region. Just to bring a bit of topic in this, guys, the flu, the common flu, has a CFR of approximately 0.1. So come to your own conclusions about the dangers of COVID. Question 7.3. Again, pause the video, give these a go. Always try and remember to cancel, guys. So this is really a problem looking at cancelling. Here's one, everything's dressed up a little bit more scientifically. An air sampler collects 280 CFUs. Now what a CFU, guys, is you'll come across them in second year and third year a lot. It's a colony forming unit. So it's a bacterial, it's not really a virus because that's an assay, but it's a bacteria, guys, that when it's grown on an agar plate, you can actually see it. It forms a colony. So we would do our sample. We would then smear this sample on an agar plate. And this is the kind of thing you would get. These little dots, guys, are what you count. Each of those dots is a colony forming unit. So just, you will come across them later on. What I'm trying to say though, guys, is don't worry about the language. It's the maths we're interested in. The 45-minute doesn't really matter either. So in this case, selected value over total multiplied by 100. But it's just dressed up with a bit of science. 320 people out of a population of 2,400 are left-handed. What percentage are right-handed? So we'll push on. We take a look at the last problem type. This is the one, guys, that will catch you out the most. Determining the original value after a percentage change. So the question describes a scenario where a value has been increased or decreased by a percentage. You're given the new value, the changed value, and then you're asked to determine what was the original value. So you'll be given the new value, you'll be told by how many percentage points it changed off the original value, and then your job is to calculate what the original value was. So we just write an example. Another COVID test, So percentage of people testing positive for COVID-19 in an urban area has increased by 10% in a week to 1,705 positive tests. How many people tested positive in the previous week? Now, the most common and incorrect approach people take, guys, is they work out 10% of this value, which would be 170.5. And then they subtract it from, so they would say it's this much minus 10%, which is 170.5, and they work out their answer. But really, guys, what you've all done here is this is 100% minus 10%. All we've really worked out here, guys, is what's 90% of 1,750. It's not actually the correct answer. It's going to be close to the correct answer. It's certainly going to be ballpark, but it's not going to be precise and accurate, which as scientists is what we want. So we'll take a look at the correct way. The correct way to tackle this problem, guys, and this is your biggest challenge. You need to write an equation relating the new value to its percentage of the original. Now I'll work this example out on the next page to explain this. We need to find 1% of the original value and then find 100%. So, percentage of people testing positive, same question. So this, guys, is the key to the problem. That 1,705 represents the 100% of the previous week plus the 10% increase. So that's 110% of the original. Now, guys, we want to find 1%. So we're going to divide both sides by 110. This will give us 1% on the right, which is what we want. And we need to divide 1,705 by 110, and that will give us our 1%. Now you'll have to run off and do a little bit of maths. It's long division. And divide by 110. It'll go in once. 60 left over, etc. I'm not going to spend ages on it, guys. I want to kind of move along. But when you finish doing it, you should end up with 15.5 is 1%. So this is your long division problem here. So that's the real maths in it, guys. And now it's quite easy to get from here to 100%. The decimal point is going to move 2 places. We multiply both sides by 100. And we get our new value there. And if you test that, guys, against the one I was saying, you will notice there is a difference. 1705 minus 170.5. That will not give us the correct answer. It will be close, but won't be accurate. So I hope you got this technique. Now, again, guys, there's another video on Moodle. So if you want to kind of tease this out, there's another video on Moodle on percentages, and you can see some different examples being worked out. I think I call it the third type of question. I just categorize them type 1, type 2, type 3. Here's just the problem for you guys. So pause the video. Price of a hospital ventilator has increased by 8% and now costs this much. So the key here, guys, is we have the new value. We know how much it changed. What is the cost of the ventilator? What's the original cost? So anytime, guys, you're given that scenario, new value and a percentage change, and asked about the original, you must use this technique. Don't work out 80% of 35,100 and subtract it, because now all you have to work out is 92% of 35,100. Whoops, sorry. So the most vital step here, guys, and when I used to kind of do written work with you in the exam, you guys won't have an exam. If you wrote that, just that, you would get at least 30% for that written question, just because it shows you understand the method. And that, guys, all the time, that's what I'm looking for. I don't really worry too much if you make a mistake on the way, especially when you don't have a calculator. But what I'm looking for all the time is that you can show understanding. And when you're writing out your problems, guys, when you're doing these problems out, I'm not there to kind of tug at your sleeve and say this is right, this is wrong. But you should always write your answers, guys, as if you're explaining your answer to your 12-year-old niece or nephew. That's, you know, this clear step by step, not trying to take 3 or 4 mathematical moves in each step. At each step, guys, you just make one move. Look at another example, 7.5. Again, guys, pause the video. And now this is a little bit more scientifically written. Blah, blah, blah. Concentration of ciprofloxacin. It's an antibiotic. I just looked it up for something looking complicated and medical. In a patient's bloodstream has been continuously monitored. Over a 6-hour period, it dropped by 40% to a new concentration. Now again, guys, don't worry about all the numbers here. What the 60.5 is the key. 60.5 represents what percentage of the original blood concentration. And this should be your starting step. I'm not going to do any more, guys. I'll let you figure it out from there. But it's critical that you understand that step, that you write the new value as a percentage of the original. So we leave it there, guys. Make sure to have a go at those questions. Have your answers nice and neatly written out and ready to go for the test. And we'll finish up here. So in the next lecture, guys, lecture 8, we'll start looking at percentage error and absolute and relative percentage differences. So thanks for watching, guys, and we'll chat to you in lecture 8. Oh, there's the rest of the question as well. Sorry, I should have put that up. Anyway, you pause the video so you can have a look. Okay, guys, thanks again, and we'll chat to you next lecture.